Hey, Mrs. Girot here, and it looks like you could use some help on the Unit 2 test. So you should be getting an A on the test because all of the answers are in the online textbook. And so when you're not getting an A, that tells me maybe you need some help with reading. But I want you to reach out to me and let me know what you need because I don't want you to fail the test. Because for me, I know it seems easy. Maybe it's not for you, but you need to communicate that to me. So, Unit 2, how it all works. Basically, at the very end of that, you have that test, and you right click on that and you open that in a new window. Okay. And then you size that down once you've got it opened. Okay. And then I just minimize that and make it as small as I can get it while still seeing it, and I move that over to one side of my screen. Now, my other window that has my units in it, the textbook, I'm going to open that up, okay? And I'm going to be reading that while I do the test. And I go ahead and size that down so I can kind of toggle back and forth by hitting Alt and Tab. Why? It won't toggle for me because I'm making a video. Okay, so let's get on with it. Remember I told you in class or in that last summary video of class, and if you guys really need to watch those videos, if I give you a video, you need to watch it. I said that the questions on the quizzes or tests, whatever you want to call them, go in the same order as the textbook. So you start with your first question. What port in your computer will you use to plug in your camera? USB, serial, firewire, Ethernet. So what port? So I'm looking for keywords, okay, as I'm reading along. There have been two great revolutions in photography since its invention in 1826. The first camera in 1888 when hand the first came in 1888 when handheld cameras and roll film were introduced. You no longer had to use bulky cameras or tripods with metal or glass plates. This allowed almost anyone to take photographs. The second revolution came in 1994 when the digital camera was introduced to photographers. In the decades since 1994, digital camera has replaced nearly all of the film cameras. The digital camera has moved photography from the darkroom to the computer. And while it may seem quicker and easier, there are some basic photography principles you have to know. In this course, you will learn about the digital camera, how it works, and how to use your digital camera. You will learn what you need to make your computer an effective digital darkroom and how to use your digital darkroom. The focus of any photography course, however, is the photograph. Photography is learned by doing. In addition to the quizzes at the end of each unit, you will have, and that's not true, we're probably only going to have 3 or 4 photography assignments, which will give you the opportunity to apply what you have learned. And yes, all of the images you produce for your assignments have to be school appropriate. Did you see anything about ports, USB? Nope, not yet. Okay, what are photographs? We see them everywhere. Maybe we see them so much that we take them for granted. We see them in magazines, newspapers, and textbooks. We see them on t-shirts, television, on radio. Okay, maybe not on radio, but on the billboards advertising the radio stations. They're online, on our cereal boxes, and on our cell phones. If we try to count them all, we'd go nuts. Look around your workspace where you're doing your schoolwork and see just how many photographs or images you can count. Quite a few, huh? Most photos are family pictures taken on vacation to help remember places and events and to share with family and friends back home. Look around you now. Do you see any photographs? Are they of people or places? What do you see in the photographs? Now we've all taken photographs and it's simple, right? Just look through the little hole in the camera and push a button. When this kind of photography was new, one company's slogan was, "You push the button and we do the rest." Have you ever looked through all of the photographs you've taken looking for a really good one and wondered what happened? So much for simple. It's easy to make a photograph, but it's hard to make a photograph that expresses what you want. What's the secret? As a photographer, you are a storyteller, telling the story to the people who will see your photos. It doesn't matter if the subject is the softball game, the family gathering, or the day you spent at the beach with friends. You are telling other people about it. And that is what this class is all about, learning to use the tools and techniques of photography and to be the best storyteller you can. So let's get started. Okay, what are we looking for, guys? Do you remember? What port in your computer will you use to plug in your camera? All right, there's a little, here we go, how it all works. Photography has always been based in technology. In the early days, it was both operating the camera and using chemistry. The photographer had to mix all the chemicals and spread them on a glass plate. Then came operating the camera. Finally, it was back into the darkroom for more chemistry. If everything went okay, there was a successful image. We have come a long way since then, but there are still things a photographer needs to understand. The manufacturers want you to think photography is bulletproof now, but there are still things you need to understand to make your images really successful. On the technical side of things, you need to understand the basics of a computer system that takes the place of your darkroom. And there are some things you need to understand about how your camera works. These will give you the foundation for taking and processing your photographs. And it really isn't as painful as it sounds. Yes, it is. Just kidding. All right, before digital photography, there was the camera with all of the lenses and gadgets. Then there was the dark room with enlargers and trays of chemistry. These two parts of the process were always thought of as being very separate. But in digital photography, we need to think in terms of the entire system. Settings in the camera can affect how the image is processed, the size of the image, or how the image is printed. The computer is the digital darkroom. Whether it is a desktop or a laptop, it has to be thought of as part of the system you use to make the final image. This is true whether the image is going to be printed, displayed on the internet, sent in an email, used in a school paper, used in a letter, etc. Here are the objectives. You're going to evaluate your computer for digital darkroom use, analyze problems in the monitor display for digital imaging using agreement ramp, calibrate the monitor display for digital imaging, and identify the software you will need for your digital darkroom. The computer. If your computer has a built-in media card reader, or perhaps you have one in your printer, you can ignore this page and go to the next. To get your digital darkroom ready, make sure you have an open USB port on your computer so you will be able to plug the connector from the camera into the computer and transfer your image files. If you don't have an open USB port, you will have to unplug something so you can connect your camera to your computer when you want to move your image files from your camera to your computer. Some new technologies allow images to be transferred to your computer even without cables and USB connections. They include Wi-Fi enabled digital cameras and memory cards, Bluetooth wireless transfers, and cloud-based media transfers and storage. Let's see, what was the answer? So what port in your computer will you use to plug in your camera? An open USB port. So you'll be able to plug the connector from your camera into the computer to transfer your image files. You need to find the answers. Don't guess. Question number 2. How much RAM or random access memory is recommended for your computer to be used as a digital darkroom? So you need to look at a few things to make sure your computer is ready to work with digital images. You don't have the latest fire breath breathing machine, but you need enough memory, at least 1 to 2 gigabytes of RAM or more. Bum, bum, bum. There's the answer. 1 to 2 gigabytes. Do you see how this works, my friends? This is especially true if you are the kind of computer user who has a couple of programs opened and a chat going while working on other stuff. To archive and back up your photographs, it's a smart idea to invest in a relatively inexpensive external hard drive, such as a thumb drive, a USB, um, card thing, not card, but you know what I'm talking about. If your computer's hard drive fails, or your computer breaks altogether, you won't lose all of your pictures if you back them up. Cloud-based media storage is also a good idea and basically does the same as an external hard drive, storing your images as ever important backups. You need a big enough hard drive to hold the images you are working on. Usually a 100 plus gigabyte hard drive will do for your computer, or a 500 plus gigabyte external hard drive. Again, all for the purpose of backing up your digital image files. Okay, how much RAM? We did that one. Next question, what kind of drive will you use to archive your photographs? External hard drive. What is the minimum hard drive capacity for storing digital images? 100 plus. Oh, wait a minute. You will need a big enough hard drive. Your home is usually 100 plus, and this is for storing. Okay, so I guess when we're talking about storing, we're talking about backing them up on your external hard drive. So we'll just go ahead and go with the 500 gigabytes since 100 wasn't an option. Seriously, if you have a thumb drive, however many pictures you can fit on your thumb drive, that is acceptable capacity for storing that many digital images, right? So you don't have to go out and buy a giant external hard drive. You can just use a thumb drive. All right. In order to prepare your monitor for digital darkroom work, you have to, okay, we haven't gotten there yet, so let's see. Checkpoint. I'll let you do the checkpoints. The monitor. The next thing you need to do is make sure that your digital darkroom is ready to work with images. To calibrate your monitor so the colors look right and the blacks look black and the whites look white, okay? Calibrate it. Ding. Question 6. The final thing you need to do to get your computer ready for digital darkroom work is to, using the gray ramp image, adjust the brightness and contrast controls of your monitor so you can see as many of the 21 steps as possible. If you have to make a choice between seeing steps on the light end or the dark end, choose the light end of the ramp. To start calibrating or adjusting your monitor, locate the monitor control, usually found just below the screen. Adjust the contrast setting almost all the way up to the highest setting. Next, adjust the brightness. If you cannot see more than about 17 steps, add a bit more contrast. Keep this process going until you can see as many steps in the ramp as possible. But don't go crazy on this. Use only enough adjustment to see as many steps as you can. On my computer, I just did a search. I don't know if you have that, but I just searched calibrate, and I got this little calibrate display color, and then it kind of leads me through how to calibrate it. So it might not quite go like this on your computer, but I'm sure if you just do a search for calibrate, you'll figure it out. All right, so let's go back. What's the question? The final thing you need to do to get your computer ready for the dark room is to, all right, let's see. The software. The next step in making your digital darkroom ready to go is to make sure you have the software you need and that it all works properly. There are a number of high quality photo editing software packages available. Some of them are freeware. You can download and use them for as long as you want. Hopefully you can hear me. Other packages you have to buy, but many of these manufacturers allow you to download a trial copy that you can use as a test to see if you really like it. But for this class, we will use an application called GIMP, which you've already downloaded, right? And you've already practiced using. You'll learn more about this soon. After you decide on what software you want, you should use it enough so that you're reasonably familiar with how it works. Don't be a software hopper. You will never really learn how to use a certain program if you're constantly changing to another package. So let's see, the final thing you need to do to get you ready, make sure you have the appropriate software. Register, no. Install, no. Install, no. I'm gonna go with make sure you have the appropriate software. All right. The heart of the digital camera. Let's see. The software continued. There are 3 types of software you will need in your digital darkroom: image processing or editing. This software lets you change the size of the image, adjust the brightness, contrast, color, sharpness, etc. of the image. You need to be really familiar with this software so you can work on your images efficiently. Image viewer. One thing that is very true but not very well known is that different software packages display photos differently. You need to have an image viewer or two to see how your photographs will look in different software. You can also check how your photographs will look in your web browser. If they don't look the way you want, you can go back into your image editing program and make the needed changes. So, like if you email it to yourself, you can see how that image is going to look in an email, or if you post it to a blog, or if you put it on Facebook. So those would be image viewers. Image organizer. This piece of software is really optional. If you're not familiar with folders and how to store your files, you can use this type of software to organize and store your images. I personally like to store my photos by date. So if you do it by date, it's really easy in your folders to see, the chronological order of your photographs, but you can also put the subject as well. So if you put the date and then like trip to California, then you'll always easily be able to go back and find those images. So make folders that are dated with subjects. Okay, that's how I do it. And self-check. Now that we've looked at the elements in the digital darkroom, we're going to do that in a second. So the heart of the digital camera is we haven't gotten to that, huh? All right, the connector your camera uses to transfer files to the computer is your USB port. Permanently storing your image files on a CD or DVD is called archiving. Your computer may be many things, but now it is also your digital darkroom. Adjusting your monitor to correctly display photographs is called calibrating. The image you use to adjust your monitor is called gray ramp. The controls you use to adjust your monitor are the brightness and contrast. Okay, how the digital camera works. What do you think this is a picture of? A sensor chip inside of a digital camera. While digital cameras can be large professional models, small enough to fit in a pocket or built into a phone, they all work the same way. The heart of the camera is the sensor. The heart of the digital camera is the sensor. That's our next question. The basic colors used to record any scene are, okay, the sensor has millions of light-sensitive receptors etched into its surface. Individual receptors are called pixels or a picture element. The sensor size is determined by the number of light-sensitive receptors it has, referred to as megapixels. 1 million pixels is equal to 1 megapixel. A camera sensor with 15 million receptors is called a 15 megapixel camera. And while there are millions of pixels on the sensor itself is very small, often no larger than the fingernail on your little finger. Describe how a digital imaging sensor works. Explain how an image is processed in a camera. Describe how the image is stored in the camera, and explain what the shutter and aperture do. How your camera works. Color photography, film, or digital, uses just 3 basic colors to record every scene: red, green, and blue. Green, blue, and red. The device in the camera that converts the sensor output into a digital signal is a special filter in the sensor makes a portion of the receptor sensitive only to the red component of the light being reflected by the subject. A portion of the sensors are sensitive only to the blue, and a portion only to the green, just like your eyes. Each receptor records only a very small fraction of the overall scene. When all of the receptors in the sensor are put together, you have the overall photograph. Let's see if this says, device the camera that converts the sensor output into a digital signal. All right, when the light coming into the camera through the lens strikes a receptor in the sensor, the receptor generates a tiny electric current that is sent to a special processing chip that converts it to a digital signal. This chip is called an analog to digital converter. AD converter. If we look at the output of the sensor directly, it would look terrible. The brightness and contrast would be off and the colors would look horrible. To make the photograph look like the scene you saw, the digital signal is sent to a second chip where the colors are corrected, the brightness and contrast adjusted, and other things in the image are adjusted. In the final step, the adjusted digital image is written to the memory card in your computer. This image is later transferred from the memory card to the computer. We'll see how that's done later. All right. The universal file format for photographs. Okay, we're going to get to that. All right. The three basic colors your camera records, red, green, and blue. 1 million pixels. Oh, it didn't even talk about that. That's a megapixel. Mega million. These are etched onto the surface of the camera sensor. Light sensitive receptors. Also known as a picture element, the smallest unit of a digital image, pixel. Where your image files are stored in your camera, memory card. The older material images were stored on film. The image file. The camera stores the image in a universal file format for storing digital images called a JPEG. JPEG, the universal file format. Good job. Computers, emails, word processing, and photo editing applications all read this file format. JPEG is one of two formats that are used in digital photography. The other is a TIFF file, and we'll get into that when we look at image processing. The JPEG format compresses or makes the megabyte size smaller by about 90% for storage and decompresses or expands the file when it is displayed. Let's see what the next question is. When a JPEG file is compressed or made smaller, it is reduced in size by about what percentage? By about 90%. That's huge. All right, the camera will assign a name to your photograph. It won't be a very descriptive name. The photograph of your dog, Rover, may be named DCIF1034.jpg or something similar. You can change the name of the file later, but you have to keep the three letters JPEG after the dot. JPEG tells the computer that the file is an image or photograph. Depending on what software you have installed on your computer, this extension will tell the computer which program it can use to open the file for viewing and editing. Compress file format for images. JPEG. Extension of image file format, .jpg. Too much light striking the sensor, overexposure. Three basic colors that your computer records, red, green, blue. Controls used to calibrate your monitor, brightness and contrast. Exposure. The most important thing the camera does after recording the image, of course, is to control how much light gets to the sensor. This is referred to as exposure. Sensors are very sensitive to light, and if too much light hits it, the image will be overexposed, like an overly bright image of a park and the sky in the background. If too little light hits the sensor, the image will be underexposed. When too much light hits the sensor, what happens to the photograph? It is overexposed and looks bright or washed out. When a photo is too dark, what has happened? Too little light has entered the camera and the picture is underexposed. Where are we at here? When you rename a photography file, you have to make sure you retain the letters .jpg after the file name. Controlling how much light strikes the sensor is referred to as exposure. The part of the camera that controls how much light strikes the sensor is there are two controls of the camera that determine exposure. The first was aperture. The aperture is a variable size hole in front of the sensor that gets bigger to let more light in or gets smaller to let less light in. This is determined by how much light is being reflected by your subject. The part of the camera that controls how much light strikes the sensor, aperture. On bright sunny days, there's usually a lot of light being reflected, so the aperture or hole is made smaller to cut down the amount of light. On dark, dreary, overcast day, there is not as much light being reflected, so the aperture is made a little bit bigger. If you are inside, even if it looks really bright, the aperture gets really big to let in as much light as possible, but there still may not be as much light as needed, so the flash will fire. The part of the camera that controls how long light strikes the sensor. Ooh, let's get to that. The shutter. The shutter is the other control and determines how long the sensor is exposed to light. Cameras in a class called DSLR, digital single lens reflex, or digital cameras, I call them the fancy digital cameras, have full mechanical shutters that open and close in a fraction of a second to record the scene by letting light fall on the sensor. The speed of the shutter can be adjusted manually, or it can be left under the control of the camera's processor. Compact digital cameras, cell phones, cameras, etc., don't have a true mechanical shutter. Rather, they simulate the shutter electronically. They will record the scene for whatever fraction of a second is called for. The time that the shutter is open or allowing the sensor to record the scene is referred to as its speed. The shorter the time the shutter is open, the faster its speed. Regardless of whether your shutter is mechanical or simulated, on bright sunny days, fast shutter speeds will be used. On cloudy, dreary days, a little slower shutter will be used, and inside, really slow shutters will be used unless the flash is fired. And if you are trying to photograph like the stars in the sky at night and you're outside, or if it's dark and you're trying to get lights, you're actually going to hold that shutter open, okay, for a really long time. And the part of the camera that controls how long is the shutter. All right, balancing light and dark. Don't forget to make the best exposure the sensor needs. To make the best exposure, the sensor needs a certain amount of light. The aperture and the shutter work together to control the amount of light entering the camera so the sensor has the amount of light it needs. And this is dependent on the light striking the subject and being reflected. On bright sunny days with a lot of light, the camera will use fast shutter speeds and small apertures. On cloudy, dreary days, the camera will use apertures that are bigger and shutter speeds that are a bit slower because there's not as much light available in this scene. And if you're inside, even though it seems really bright, the camera will use really slow shutter speeds and really big apertures because the amount of light available is really low. Look at the difference between these three exposures below. Here's an underexposed picture. Here's the correct exposure, and this one's overexposed. And that's it. So we finished the Unit 2 test. You'll save all of your responses. Let's see here. Make sure you save all your responses, okay? And then submit it. All right, and you should get a perfect score.